G'day guys, I've got a trigonometric identity problem for you today, which I've been asked to do a few times in some of the classes that I give. I thought I would over time just build up a bank of all of these different trigonometric identity proofs, so in the future you'll be able to just come to my channel and I guess see if you can find the one that you're looking for. So today we've been asked to prove the following trigonometric identity. We've got the sine of 2x take the sine of x all over 1 minus cos of x plus cos of 2x, and that's supposed to be equal to tan of x. So what I've done on the right hand side here is I've given you guys the sort of the basic trigonometric identities that I'm going to use to prove this particular identity here. And yeah, so these are the ones that you're going to have on hand, sort of ready to go, remembered in your brain if you were to see this particular question in an exam, if you weren't given them in a sort of a notes page. But to be perfectly honest, guys, when you're given trigonometric identity problems in an exam, if you've got them written on a notes page and you're not very well acquainted with how they work, and so you probably know them off the top of your head anyway, you're not going to be able to use them to solve particular problems like this because you're just not going to be able to see where they're going to fit in. Okay, so let's get a move on. The first thing that we've got to do in this trigonometric identity is basically break down the sine of 2x and that cosine of 2x. And we're going to use these top two trigonometric or angle sum formulas here. So we're going to say that the sine of 2x is going to be equal to the sine of x plus x, and that's going to be minus just the sine of x. And that's all going to be over 1 subtract the cosine of x plus the cosine of 2x, which, like the sine of 2x, we're going to say is equal to the cosine of x plus x. Cool. So, why have we done that? Well, we've done that so we can expand out these two angle sums here using, well, for the sine one in the numerator, we're going to use this top one here, the sine of a plus b, with a being x and also b being x. So what we're going to get is, let's take it down to the next line. So this is going to be equal to the sine of x times the cosine of x plus the cosine of x times the sine of x. And then we're going to just minus that sine of x that we've got on the end. And then that's all going to be divided by 1 minus the cosine of x. And then we're going to expand this one, plus we've got the cosine of x times the cosine of x minus, because it's always the opposite with cosine, the sine of x times the sine of x. Cool, so I'm doing this sort of the longhand for you guys here, just so you can see exactly what I've done. But in an exam, I would probably take this straight to just, like this second one here, to cos squared x minus sine squared x, just to save time in an exam. However, we're not in an exam right now, and it's just important that you understand what the hell's going on. So what I'm going to do is, with the numerator, this part here, sine of x, cosine of x, and this one here, cosine of x, sine of x, are the same thing. So they're like terms. We're going to be able to add them together. So I can say that in the numerator we're left with 2 sine of x cosine of x, and that's going to be minus sine of x, all divided by 1 minus cosine of x, and I'm going to just put this into cos squared and sine squared. So we have cosine squared of x minus sine squared of x. Cool. So, where to from here? As you can see, where we're at the moment looks absolutely nothing like tan of x, but you've just got to trust the process, I guess. What we're going to do in the top is we're going to factorize this by sine of x. Or when I say the top, I mean the numerator. Let's use a bit better terminology, mate. So we're going to have the sine of x as our common factor. And that is being multiplied by 2 times the cosine of x subtract 1. Cool. And in the base, what we're going to do is, this is something that's, well, I think is quite clever, and a lot of kids in exams don't really see it. In the base here, we've got all cosines except for this sine here. So when we have a squared, we can substitute cosine into here using the third basic trigonometric identity, the Pythagorean identity down the bottom, because we can say that sine squared x is equal to 1 minus cosine squared of x. So what I'm going to do is I'll write that down here for you guys. It's going to be 1 minus cos squared of x. So I can substitute that in, and I've got 1 minus cosine of x plus cos squared of x. Now, especially when we have negative signs here, guys, when I have to substitute in something, I always like to go minus, and then I'll put a bracket. 1 subtract cos squared of x. Now, the reason for that is so I just don't screw up my signs out the front of my numbers. So I know here that this is going to be minus 1, and a minus and a minus will make a positive cosine squared of x. Okay, so that's that part done. So in the numerator, we're not going to do anything at the moment. We're just going to leave that as it is. We'll just chill on that. And in the denominator, we're going to combine our like terms. So what do we have? We've got 1 minus 1. So the 1's in the denominator are going to cancel out. And we've got minus cos of x. That'll stay. And we've got cos squared of x minus cos squared of x. So that'll be plus cos squared of x. So in the denominator, we're left with 2 cos squared of x minus cosine of x. Now, the more astute viewer will sort of be able to see where I'm going to go from here to tan of x, but for those of you who can't see straight to the end, I'm going to factorize my denominator now. To cosine of x take 1. Now, this is the most satisfying part of the problem. The 2 cosine x take 1, 2 cosine x take 1. They will cancel out. And we're left with, this is equal to sine of x over cosine of x, which hopefully you all will know is equal to, the right hand side of the problem. So, what did we do, guys? Well, the first thing that we did is we split up these sine of 2x's using our angle sum identity. We are able to say that sine of 2x is equal to sine of x plus x, and the same with cosine of 2x. These questions in exams, mate, are massive. They're a massive pain in the ass to write down all the cosines and sines over and over and over again. But I would suggest doing it like this in an exam rather than skipping steps to save sort of valuable pen scribbling time, just so you don't make any silly mistakes when you're timesing out brackets or factorizing or anything like that. So it's all worthwhile when you get the answer right in the end. So what we did is once we've done our angle sum identities for both cosine and sine, we're able to, in the numerator, combine like terms, and in the denominator, we substituted the minus sine squared x out for 1 minus cosine squared x using our Pythagorean identity, the third identity in this text box here. Once we'd done that, we're able to combine our like terms in the denominator and then factorize. And then once we'd factorized, we were able to cancel the common factors in both the numerator and the denominator because the quotient of both of them is 1. Once we did that, the remaining part was sine of x over cosine of x, which we all should know is equal to tan of x. And tan of x is equal to the right-hand side of our identity here. So guys, I hope this video helped. As I said, I'm trying to build up a sort of a collection of trigonometric identity problems on my channel. If there are any particular trigonometric identity problems that you're having trouble with, leave them in the comments section below. I'm always looking for new video ideas, and the comments are usually a great source of inspiration for me. But guys, the only silver bullet to being able to solve trigonometric identity problems under pressure in exams is practice. It's the only way you're going to be able to get better at these, is practice, practice, practice. Watch some videos so you're not banging your head against the wall too often. But eventually, guys, if you keep banging your head against the wall, eventually it'll fall down and it'll all start to make sense. You just have to trust the process. And when you're up here in the problem, it may seem like, wow, there is no way to get to the particular solution at the end. But you just have to keep persevering and seeing how you can simplify it, seeing what identities you can use to substitute in and out particular ratios. But in the end, hopefully you'll see that you're starting to, more often than not, get to the solution that you're after. So I hope the video helped, guys. If it did, give it a like. Subscribe to my channel. I put out new videos all the time. But until next time, guys, just make sure you keep on enjoying your maths. I'll see you again soon.